At Google Cloud Next 2026 in Las Vegas, Alphabet dropped two announcements designed to cement its position in enterprise AI and to break Nvidia's chokehold on AI silicon. First, for the first time ever, Google has split its TPU lineup into two purpose-built chips, TPU-8T for training and TPU-8i for inference. Second, a $750 million partner fund, the largest single partner investment from any major cloud provider. Let's start with the silicon. The TPU-8T, codenamed Sunfish and designed by Broadcom, is the training chip. It scales to 9,600 chips per SuperPod, delivering 121 exaflops of compute and 2 petabytes of shared HBM memory, all connected by Google's new Virgo scale-out fabric, which can link up to 134,000 chips in a single data center and up to 1 million chips across a multi-data center training cluster. Google claims 2.7 times better price performance than last year's Ironwood. The TPU-8i is different. Codenamed Zebrafish, designed by MediaTek, bringing mobile efficiency logic to the data center. It targets inference and AI agent workloads. 1,152 chips per pod, 11.6 exaflops of FP8, 288 gigabytes of HBM, plus 384 megabytes of on-chip SRAM, triple Ironwood. It includes a new collectives acceleration engine that cuts on-chip collective latency by 5x and abandons the 3D torus for a new board fly topology that slashes network diameter by 56%. Bottom line, plus 80% inference price performance over Ironwood. Both chips hit 2x performance per watt, 12.6 petaflops of FP4 compute, and plug into Google's unified AI hypercomputer stack. As Chief Scientist Jeff Dean said, it now becomes sensible to specialize chips more for training or more for inference workloads. The general-purpose AI chip era is ending. Now the $750 million fund. Kevin Ichipurani, head of Google's global partner ecosystem, told the audience agentic AI will create a roughly $1 trillion global market, and Google intends to capture a disproportionate share by making partners its primary delivery channel. The fund targets Google's 120,000-member partner network, consulting firms and systems integrators like Accenture, Capgemini, Cognizant, HCL Tech, and TCS. It covers AI prototyping, agent deployment, upskilling programs, and Google forward-deployed engineers embedded at partner firms. And partners are matching the bet. PwC pledged $400 million of its own. KPMG committed $100 million more. The economics driving it all? For every dollar a customer spends on Google Cloud, partners capture up to $7.05 in services revenue. On the Nvidia challenge, let's be honest about the comparison. Nvidia's Rubin beats the TPU-8 per chip, 35 petaflops of FP4 versus 12.6, 288 gigabytes of HBM4 versus 216, and faster per device interconnect. But that's the wrong frame. When you train a frontier model, you're not using one chip. You're using hundreds of thousands. Google wins at scale, 2.8x the perf per watt of Nvidia's H100, and a supply chain now diversified across Broadcom, MediaTek, Marvell, in talks for a third TPU variant, and Intel for CPUs. Anthropic is the anchor customer, 1 million TPU chips and 1 gigawatt of capacity in 2026, expanding to 3.5 gigawatts by 2027. Google's infrastructure spend hits $175 to $185 billion this year, nearly doubling from $91 billion in 2025. Why it matters? 3 things. First, the general-purpose AI chip is dying. Training is a batch process. Inference is a high-velocity swarm. Specialization beats versatility now. Second, partners are the delivery engine. Google bets that systems integrators own enterprise adoption, and $750 million is the down payment on that channel. Third, Nvidia's moat is now economic, not technical. Google can't beat Rubin per chip, but it can beat Nvidia on integrated cost at data center scale. TPU shipments projected at 4.3 million in 2026, 10 million in 2027, and more than 35 million in 2028. Bottom line, Google isn't matching Nvidia chip for chip. It's changing the game board.